Alright, welcome back. I am aware that my music contains singing, which can be distracting, and I can mute the music. Honestly, it's probably the safer bet. But I don't really care. No one really listens to listens to music during math. But yeah, we left off at this question, which we aren't able to complete. So let's do this. So before we continue, I just want to make sure we know what we're going towards. So I just realized that I didn't actually complete my trigonometry section. I actually didn't complete that. I left it off at a certain point, at 6.4 out of I think 6.7 ish. Whatever. So then after that, there's obviously integration, which I'm doing currently over here, and actually before all of this, differentiation in between, I completed that. Honestly, I don't know why that specifically I completed, but I did. Well, I mean, if there's anything left from differentiation, that's going to be like the end of unit questions. I'll probably do those before like an exam or like a test. So yeah. But actually, one thing I have left is sequences. Now, I actually did not do the end of unit test for these, and now that I'm coming into integrations, and I'm just noticing that sequences is kind of involved, or at least I'm noticing that in the proof of integration, or at least the proof of finding the area using the trapezium rules and whatnot, the proof using sequences is being relevant, and that's where my knowledge of sequences is kind of being tested, and I've kind of forgotten everything. Like, I've realized that looking back at it, I've forgotten pretty much everything. So that's a problem, of course. So yes, these three is what I'm really focusing on: sequences, integration, trigonometry. What I'll do, I think this time I'll continue with integration, continue until where my class left off, or rather where my tutor left off. Trigonometry, I'll go until where, I'll just finish it, except of end of unit. And sequences, I'll go until where I feel comfortable, where I feel like, yeah, okay, I remember most of this. So yeah, that's gonna be the diagram that we're gonna be following. So I think we can erase this. Okay. Honestly, this music is kind of not it. Like, I enjoyed this song. I'm already gonna spend this time to watch music. Oh, bruh, Reza Arc came out? Bruh, I did not know that. New RT game video. Shit. Okay. Right. My fault. I forgot what the type of music is called. Fruitiger. Is it called Fruitiger? Fruitiger era? Fruitiger era stream set. I'm spending this time not really on studies. Okay, I should probably pause then. Whoops. Okay, I've just turned off the music because I want to listen to my own shit. Oh my god, someone's typing. Oh my god. Yeah, I'm sorry, Millar. If you're ever watching, if you've ever somehow found out. I'm gonna focus on maths, bro. I'm sorry. This shit is actually tragic. I feel awful for my boy, but that's how life goes. Alright. So, what are we doing? We are going through this question. Stupid question. I swear to God. It's so stupid. I don't know where it went wrong. Oh God. Does anybody know where they go wrong in life? Alright, okay. So I don't know how well I was explaining this, but this portion is perfectly okay. This portion is okay because this portion is okay. Oh wait. Yeah, no, yeah. This portion is okay. This portion is negative, positive, and this portion is negative because this is actually a negative with a negative, and then it turns into a positive with these double negatives. So now this is somehow wrong, which means that this is somehow wrong. So we need to figure out why it's wrong, right? So it says minus 81 over 4, so this is fine. Then I wrote 4 times minus 9, which is minus 36. And over here it says minus 108 over 3. So that's where our first difference lies. Minus 108 over 3, but doesn't that just equal to... Yep, minus 108 over 3 just equals to negative 36, which is just 4 times 9. Yep. So, okay. Don't know why they keep it in an unsimplified form, but that's correct. Then there's 99 over 2 positive, which is correct. Then negative 3 times negative 30, which is positive, correct. So this is probably just addition wrong on their side. I will use Wolfram Alpha to just fact check. So if I could just do like, I don't know. Can I use Wolfram Alpha for this? I should probably not. I'll just do it on my own. So we have minus 81 over 4 minus 108 over 3 plus 99 over 2 plus 90, and that gives you 3. Yep, that gives you negative 333 over 4 in a mixed fraction. That's 83 over 1/4. Oh my god, wait, hold on. There's 1/4. Oh my god, wait. Is this mixed fraction not simplified? Nope, this mixed fraction, their answer is just straight up different for the same, I don't know, the same calculation. So, wait, no, hold on. No. No, that's a sum. Okay. Okay, so that's 333 over 4. Negative 333 over 4. Negative 333 divided by 4. And our left number is minus 94 over 3. So minus 94 over 3 gives you the correct answer. So I'm not sure how we went wrong here, because this is truly correct. Oh, that's okay. That's where we went wrong. That's annoying, but yeah, there you go. So yeah, that's where I went wrong. A simple sign, of course. That's bio. I mean, oh, whoops, that's embarrassing. That's what that is. Okay. Anyways, so let's just honestly just erase this, because this is past us now, and let's do what we need to do. So we have a negative number here, and that's going to be our total of 1375 over 12 plus this total thing. We've found out this over here. Let's just put that back. So 29 1 over 4. It is going to be a positive number. 117 over 4. I'm not sure why I put this. 117 over 4. As a result, maybe we want to times this by 3. So 117 times 3, 351 over 12, which is going to give us a negative 1375 plus ounce divided by 12. That's a total of 256, negative 256 over 3. That's one. The other one, that's our total. It's going to be a negative number, which, looking at the curve, makes sense or does not make sense? It does not make sense. Now, do we add these or do we subtract these? In this case, we're adding them. Which makes sense if you want to find the total area. But I'm not sure. Let's make this a bit smaller. Okay, so let's see what they're doing and what I'm doing. So I'm getting negative 256 over 3. Is that the correct answer, first of all? Okay, so they are subtracting both areas. They are subtracting it. And this now matters on a level of understanding. What are we really doing here, right? So, see, first of all, we should know that this area is negative and this area is positive all the time. Okay, because it's under the graph. So this area is going to be negative and this area is going to be positive. Okay, now, if this area is negative, therefore, what we would be getting is a negative area and a positive area. Okay, negative area from here, positive area from here. So now, if we subtracted both of these, it would result in what? It would result in negative a minus 1 plus, so negative, and then a minus 1, a2. These two get added together with a negative sign, which is why what we do is we take a2 first, the positive one, and do minus a1. And since a1 is already a negative number, a2 will become positive, a1 will stay, a2 will stay positive, a1 will get added with a2. So this is the reason why we, first of all, find out the second area, or rather the positive area first. We keep it in the first section, and then we subtract it with because we know that this is going to be negative. So we know that we need to subtract it so that it will become positive, so that we can actually find the total sum. See, you might think that, or subtracting out. So we're finding the, so technically we're finding the difference, but no, we're we're algebraically manipulating this so that it gives us what we need, which is the total sum. This is not some mistake or some lucky happenstance thing. This is logic. So now looking back at this, right, d- there needs to be a change. First of all, the first issue is that I put the negative number first and I put the positive number second. Okay, so if we flip these two numbers, okay, then we would be receiving something like this. If this was plus and this was minus over here, because again, just imagine them flipped. So this is A, this is B, so imagine just B minus A, because minus A is negative number. So this is what we're getting at. So then later on, which would just eventually lead to, skipping all the stupid steps, we would get 117 divided by 4. um, okay. Okay, I think this is what I should be getting. Yep, perfect. So we should be getting a simple negative 863 over, oh god, it's a negative number. Why? Oh, no, sorry, no, that's my bad. It is a positive number. Is anything from here like hiding when I'm doing this? Okay, we're good. So yeah, that's going to be our final answer, which is also correct. This was just, oh, this was the last question, but still, it's not very pleasing to be spending this long on just a question, you know. But yeah, I guess that is just what we're having to deal with. We're not very comfortable. But thankfully, you know, going further on, the principle doesn't really change too much. It's just different questions with the same idea. So yeah, now we'll go into intersecting curves and lines. So yeah, this is gonna get kind of tough. There's about 11 questions here until, okay, so these are gonna be the last 11 questions that we'll do until we literally just step off. However, how many questions are there in the areas between two curves? We're having how many questions? Just 5. Okay, perfect. Trapezium rule is explained. Very in depth, and then we have a whole thing on it, which is perfect. My friend told me it takes about 30 minutes to go through trapezium rule, so I think I'll be going through it tonight, but not before I complete these 11 questions, which God knows could probably take me the entire night. So I hope not. Let's just try to breeze through these as quick as possible. Question 1 I've already done, so let's do question number 2. We'll zoom in, I think, fairly in like this. Should I move my graphics tablets to my lap? Like then it gets like pretty uncomfortable to write down over here. So I have to like kind of just keep it up here, which is not really nice. What is like the best way? Like I know tilting it is good, but tilting it is kind of impossible for me. Yeah, I'm not really sure, dude. I'm not sure at all. Yusuf is studying, dude. It's 11 o'clock. It's hilarious. But anyways, let's keep going. I'll just study how I'm always studying. I have this armrest, which really helps. The keyboard, I always like to keep it tilted towards my hand. I just wish this keyboard wasn't so chunky. Like, alhamdulillah for everything. It's a great keyboard, but it's huge. It's huge. Okay, so let's get this. So let's make this a bit wider, so I can see, yep, this is perfect. So let's draw the equation first of all. So we're having just a simple, I don't want to spend too long on this, so we're just gonna, it's gonna go to the origin, we're gonna go like that. We're seeing a line y equals to 3. So y equals to 3 over there, and just the red region is what we're looking for. This is 0, this is 4, and that's it. The line itself is 4x minus x squared. Okay, so now we have to find out coordinates a, b, and region r. So easy peasy. So 3 equals to 4x minus x squared. X squared minus 4x plus 3 equals 0. X is going to be what? So this is going to be 1, this is going to be 3. Now find the region R. So to find the region R, okay, this is kind of where I want to be able to see the graph constantly. And so I need to see the graph, and I also need to be able to be zoomed in. So at that point, I think it's like, this is the point in time where it's like, I have to zoom out just a little bit. So I can just kind of visualize everything. Okay, so this is going to be our two sections, this and this. We're going to be having the rectangle, and we're going to be having the curve, and we're going to be subtracting both. Seems easy enough. Like, that's kind of what we're dealing with. Okay, so we can do this. 3, 1, and we have 4x minus x squared. We can use this equation here. So x squared minus 4x plus 3. I'm actually not sure. Let's test that out, right? So now 1 over 3x cubed minus 2x squared. Let's actually just, no, it's fine. Plus 3x, 3, 1 over 3, 3 to the power 3 is going to be 27, minus 2, 3 to the power 3 is 9, plus 3 times 3, minus of your 1 over 3 minus 2 plus 3. That's going to give you a total of 27 over 9, that's going to be 1 over 9, that's going to be 18, that's going to be 9. So we're going to have 9 plus 9 minus 18, which is a 0. Is that right? 9 minus 18 plus 9. Okay, and then we have minus 1 over 3 minus 2 plus 3. So 1 over 3 plus minus 2 plus 3, which is a total of negative 4 over 3. Now, what is the issue with this? The issue is probably that you're not supposed to do what I did. Read question number 2. Okay. Okay, so it is 4 over 3. It's not negative 4 over 3. The reason why we're messing this up could possibly be because we're doing you see it shows 18 as positive and the 2 9s as negative. So it's actually that this just needs to be the opposite of what I've actually put it as. Yeah, I mean, dude, in the textbook itself, they do it the way we're doing it, so. They write it as 4x minus x squared, which is what we see it as originally, and they put a minus 3 it, so they could have put the minus 3 over here. And then they just continue. So just keep that in mind, I suppose. When we're doing this, keep the keep these sorry about that. Keep this where it is. Move the constant or the y value from the other side to the inverse. I also just want to just take a picture of this and send it to a buddy of mine, because the school textbook is also doing it in this method, and I think it's pretty important. So what is happening in this question? Area of the triangle is given by OBC minus this. Okay, let's take a different question. This is y equals to x, this is this. To find out the points of intersection, we just equate them, so we get 0 and 3. 4x minus x squared. Okay, fine. They're doing it in that method. Now if I did 4x minus x squared, which is the area of this, and I subtracted it by the equation of the triangle, which is x, that gives us this equation, which when we integrate it gives us well, it gives us 4 over 2x squared minus 1 over 3x cubed minus 1 over 2x squared. That's going to be this gone, turned into a 2. These two add up. I don't know why I didn't add these up earlier. Let's just do this again. Minus x squared plus 3x minus 1 over 2x squared x cubed plus 3 over 2x squared. We're having the sections as 3 and 0, so this is going to be 27, that's 1, that's 9, plus 3 over 2, 9, 3 nines are 27, 27 over 2, so 27 over 2 minus 9, it gives us 9 over 2 as our area, and over in the answer key it's also saying 9 over 2, so this is truly it works as a method. Anyways, so this was just some extra proving. Now the actual big deal, which is this, I think we figured that out already. And that was that in this case, the problem was we just, yeah, it should have just been this. That's the equation that we should have worked with, and if we worked with that, then by the end we would have gotten this. So yeah. Either way, I think it's still correct. I want to ask, if I get a negative 4 over 3, can I just turn that into 4 over 3? Like, can I do that if my method led me to a correct answer just in the wrong you know, thing? What is the plan? Like, let's say I did integral, I got an answer but it was negative, so it could be the correct answer but it's negative, so I need to look back and look at two things. If this is a question regarding two things, like two intersecting things, and you have to find the area for the intersection, then that would mean do it in this method. Do it in this method where you had the 4x minus x squared. equals to 3, and then you put the 3 and you turn it to minus 3. This is the method that you should be following. And the other method where you might be getting a positive when you're supposed to get a negative is over here. Was it? No, it was here. Whoops. It was here where you're supposed to just keep the positive, keep the negative on the right side and the positive on the left side. Although the negative always appears on the left side, just do that, right? So oh hell no. Wait. Oh my god, what am I doing? How much working do you think we'll see if I just open all of these? Oh my god. Oh my god. Damn, that is so cool looking. Okay, wait, that's going on the art Instagram. Art Instagram, art Discord. Opening all the layers in the math document that I use. All at once produces a pretty cool image. Oops, what the hell? But anyways, that's enough. It's enough stupid talk. That was funny. So yeah. Anyways, we're not even working on this. We're working on this. Okay, perfect. God, I'm getting distracted a lot these days now. So that's going to be question number 2 done. Moving on to question number 3. So we are seeing. Just be careful where we do all these things. So just quickly drawing a graph. Having a curve go like this. We're having a line pass straight through this. I have in this region. This is being 9 minus 3x minus 5x squared minus x cubed. This line being 4 minus 4x. Now we can really see this coming to use, this combining method. So first we want to find the intersection points. So 9 3x 5x squared minus cubed equals to 4 minus x. Then we start adding, so I want to keep it like this. X cubed, this goes on this side, so it'll be plus x. This goes on this side, so it'll be plus 5 equals to 0. Have all 4 terms. So now we need to be doing the factor theorem, if I'm not wrong. So 5 only has 1, 5, so plus minus 1 plus minus 5. If this is f of x, which does that, then this is really annoying. This would mean that there are 3 roots of x. But to us, this is a quadratic. Why is there a cube? You know? What is happening? Wait, is that a typo? What on earth? What they're saying is that there's going to be 3. But of course not. There's only this and there's only going to be this. Okay, whatever. I wonder if we actually have to do this factor theorem. We'll look at the marking scheme after this. So let's use plus 1. So that'll be minus 1, minus 5, plus 1, plus 5. Okay. So f1 has minus 1, minus 5, plus 1, plus 5, which equals to 0. That is a true statement, so that means x minus 1 is a factor, which means that if we do minus 1 divided by your minus 1 minus 5 plus 1 plus 5. Am I doing that right? No. Yes, I am. Then we would have to do 1 is minus 1. So minus 1 times minus 1 is 1. That will be minus 6. Minus 6 minus 1 is 6. That's going to be minus 5. Minus 5 is 5, which is 0. That's going to be minus 1x. Sorry. Minus x squared minus 6x minus 5 factor of x minus 1. This is going to be turned into minus x squared minus 3. Sorry. Let's turn this into positive, so x squared plus 6x plus 5, because I have such a trouble doing that. So that's it, and then we're just going to reverse the charges. X would still equal to no, x needs to equal to negative 3 here. Oh god. Okay. Okay, x can equal to negative 3. If we want to, okay, so x equals to negative 3 here. What's another way of saying x equals to negative 3? Like this. Because x needs to equal to negative 3 to turn this into a positive 3 to then turn that into 0. So this is actually what we're going to be dealing with. From there to this and x minus 1. Okay? So then, I mean, actually, truly, I don't think this really matters because these are literally the same thing. Just different ways of writing them. Anyways. So x equals to, I mean like overall, let's just erase this because it's a waste of space. So overall x equals to x equals to 1, minus 3, and minus 2. Now we're seeing here areas where these two interact is going to be here, which, well, it could be a minus 3 or a minus 2, and this could be a 1. Oh, guess what? Guess what's really funny? They actually tell you it already. They tell you where they intersect, A and B. Okay. Oh my god, that is painful. Okay. They tell you where they intersect, but A is apparently -1, which is not a factor. What the hell? Just what the hell? Did I do something wrong here? One of the factors is 1, 0, which is what we got. How is it -1, 8? Oh no, I'm getting tired now. Shit. Oh, I still have so much left to do. Oh god. Okay, let's quickly just check. Is this alright? So, I'm gonna stop talking for a while. So, 4 goes on this side. Oops, -4. 5 goes on this side, comes plus 4x, comes x. So you have x, you have 5. Is this truly a thing that they just did not think to? I mean, because this just makes genuinely no sense to me. The whole first thing, this is a cubic. Sure, they might have a thing that they're just not showing us. But perhaps we can just open Desmos and see it, right? So if we open Mr. Desmos here. Okay, so we're having the equation. I suppose I can share the screen now. What I can do is just oh, that is not what I want to show. That is a look. There you go. So I can just keep this on the left and keep this graphic calculator. This is so annoying. Okay, and then we just keep this and just smidgen this to the left. Can we not do that? How does that look on OBS? That looks awful. Order, transform, fit the screen. Transform, fit the screen. That is not fitting the screen, brother. Fit the screens. Stretch the screen? No. I don't get it. It's not that hard, is it? Just do it. Um, okay, yeah, this is shortened, so I'll move this down and I'll turn this into Clip Studio, and now that's shortened. Okay. Okay, wait. Turn this into. Okay, wait, no, it's this. There's a problem with this specific window capture. I can tell. So let's remove this, and we have put in another window capture. God, I really wish I didn't have to do all this. Okay. What is this? Yes, and just. Okay, yeah, okay. This is fine. Yeah, okay, perfect. Yeah. Oh, finally. Okay. So what are we doing again? Because I've forgotten. Yes, I just want to be able to just visualize this. So we're getting a 9 minus 3x minus 5x whole square minus x cube. Uh, um, I need to use my mouse for this, which is not very happy vibes. Okay, so that's what we're seeing, this kind of curve. And yes, this is truly not at all what we're looking at in our actual thing. Yeah, this is just not, this does not appear anywhere. So it's truly just, I don't know, I'm just confused how they could make this a question. It's question number, says 3. Man, I just wanted a clean question. Can we not have an easy question over here? Question which makes sense. They got a 5 plus x minus 5x squared minus 3x cubed. They got 5x sorry? 9 minus 3x minus 5x squared. 9 minus 3x minus 5x squared minus x cubed. And then after the 4, you get the positive 5, you get the x, you get the negative 5x squared, you get the negative x cubed, sure. And then you integral that, you put in the limits, 1 and negative 1, you get it, you get it, you get it. Okay, sure. Now that is assuming that you have the right graph in the first place, which we just don't. Like, even if we went here and put it at 4 minus 4x, so it's like, what, okay, so what we're assuming here is imagining if this line went just through it here, rather than it, like, so what in reality where it goes is like, go like this, and not only that, will it go like this, and it'll oh wait, hold on, does it intersect with the line again? It does. It literally does. You would have. Wait. But see, you need an area which actually intersects with the x-axis. None of this area intersects with the x-axis. Nor does this area intersect with the x-axis either. The only area which intersects with the x-axis is this. So we are intersecting at over here, which is a -5. We are intersecting over here, which is a -1. And we're intersecting over here, which is a 1. So, okay, that tells us a few things. First of all, it tells us that this was wrong because this tells us that it intersects at -3, -2. It actually does it at 1. It does it as -5 and -1. So we're doing something wrong here. Perhaps let's just try it again. I mean, this is not part of the what we're doing, but this is truly something I just want to be able to do. This is pretty basic stuff. Okay, now we need a value of x. We chose 1. Am I getting something different? Oh, I am. I am. Oh my god. Oh, let's go. Oh, let's go. Let's go. Let's go. I don't know. Oh, did I just write it wrong? No, no, no. Oh, no. I wrote it wrong this time. I'm the one who wrote this wrong. You see, x needs to go here and 5 needs to go here. Oh no, man. Oh no. I was hoping something's gonna be different, but nope. I don't understand. Why am I getting different solutions? Let's see, what are the solutions of this on a calculator? Minus x squared minus 6x minus 5. It's minus 1 and 5. Brother, oh my god, I'm gonna kill myself, bro. I'm gonna kill myself, bro. I just did this wrong. Of course, this is going to be minus 1 and 5, bruh. Sorry, minus 1 and minus 5. Only two things add up to this. How the hell did I get 3 and 2? 3 and 2. Wait. Oh, brother. My 3 minus 2. They'll add up to negative. I didn't really spend that much time on this. Oh my god, did I really spend that much time on this? Oh my god, oh my god, oh my god. Okay, I'm tired. What do you expect? Whatever. Okay. Am I showing my screen? Okay, it's black, right? That is, that just happened. That just happened. Anyways. What time is it? 11:44. Oh god. That is not a good sign at all. I wonder, is Yusuf still studying? I love this app, dude. It's so fun. So silly. Yusuf is gone. Dude, I was supposed to do sequences or at least trigonometry. God damn it. Oh god damn it. Oh god damn it. We need to lock in. God damn it. God damn it. Alright. Okay. No more funny business. I wasted so much time on this bullshit. Okay. So we know it's literally given -1. This is given 1. Am I even gonna do this? I'm not even gonna do this. Why should I do integration for the 50th time? I know how this shit works. It's a simple thing. Okay, this question number 4, is kind of cool. They don't give you anything. So they give you y equals to 1 minus x. This is a bit too large font. Let's just zoom it in a bit. And we can just take it from there. So y equals to 1 minus x and x plus 3, and they give you the second thing, y equals to x plus 3. So that if we drew the line, okay, then we're given that x is equals to 1 and x is equals to -3. So if we have 1 and we have, that's a shitty graph, -3, and then we have y equals to x plus 3. So that's going to be, if x was equal to 0, that would be 1 minus and x plus 3, so that would be plus 1 minus, sorry, god damn it, 1 times plus 3, so that would equal to 3. So we're having a 3 over here. So it's this kind of graph. We have a negative x, so that is going to be a sad graph. And we have x plus 3, so we have a line that's cutting through the entire thing at x plus 3. Okay, and so this is okay. So everything's fine and dandy. Yep, I think everything is understood. Find the area of the finite region bounded by the curve with the equation this and the line this. So we need to find the area that they're both manifesting, which is this. No, which is this. Yes. Okay, now, which means that we need to find this and we need to find this so that we can find this area, because this area is not being manifested by this rectangle. The rectangle is only hitting this and hitting this. Or is it? We need to find something that is hit by both the thing and the thing. So if we did it like this, but this area is not touched by the curve, so we can't use that. So can we use this? No, that's not touched by the x-axis, or at least this isn't touched. The area where both of them touch is this. The reason why we can't use this value or this value as or anything less than this value as our limit, because this is not inhabited by the curve. The curve cannot reach that side. So anyways, so simply expand this, equate this to x plus 3, find out the roots. Those roots would be this and it would be this. With those roots, you want to then integrate this big thing minus x plus 3, and that's going to be our answer. We're not going to do the working because the question is not very special. We have y equals to 12. We have x4 plus x. We have to find the coordinate point A where it meets the curve. So we need to find this point specifically. Why not the other point? Okay, yeah, now this is kind of interesting because we're not having your normal thing. Our limits now is 0 and whatever A is. This would be the rectangle, and the curve from here to here would be just nah, bro. The curve, sorry, the area with the curve would be this. So how do you find R? Because if I find the area of where the x-axis interacts with the curve, or the curve interacts with the x-axis, it would be this. Because none of these are going to be interacting with the x-axis again. These lines will not be, but from here to here, these lines are. I have no idea what they're doing here. Okay, yeah, here they're showing us a simple example. So but not really. So we need this area OAC, which is kind of similar because we're not looking for this area, which usually we would need. Can we see this on OBS? Oh, okay, no, you can't. Okay, fine, whatever. So we need that. I'm such a loser. Um, pure math for the win. 3 hours of pure math today. Can you believe that? 3 hours of pure math today. Now I can count. I'm like consistently beating Ariane. It's in terms of hours studied. Oh my god, that is so funny. Oh god, it's such a stupid thing. Oh my god. OBC is the triangle that we're using. And this. What the hell is that? X minus 3. That's going to be the length of your line. And that's going to give you this. The curve cuts the x-axis at x equals 3. So A is equal to 3. Cool. The curve meets the line. So x equals to 0 or 5. So B will equal to 5. Sure. So now we know what A and B are. We know that A is 2, A is 3, B is 5. Given that, now we know, since we know point C, because that's the intersection, now we have A, B, and C, which is a triangle. Now, we also know O, A, and C, but we don't know the curve AC. Oh my god, wait, hold on. You know the area of OAC, OBC, and you subtract it by the area of the triangle? Yep. It tells it to you straight up. OBC minus BA. Okay, see, finally, this is actually a genuinely difficult question. Okay, so we probably should have done this example. Okay, yeah, we should probably done these example questions first, because this first example question does actually tell you a lot about what you need to do. So now actually back to the actual thing. Let's erase this for now. And let's talk about this example. So in this example, we are given this, like this, and we have a line that passes this and goes out, and we have a line that goes like this, goes like that. And we need to find out this. We're gonna make it like real nice to look at. Not very. Okay, that's pretty unpleasing. Is there any like? What's a soft color? Okay, that's nice enough. So actually, can't we use like gray? I feel like just that gray is like good enough. Is there a better paintbrush? Like, I'm just having fun. Hold on, man. Let me have my fun. Like, goddamn. This is such a nice paintbrush. Oh wow. Okay, that's it. Bang. Okay, perfection. So, no, actually, we're gonna move that there because this is actually kind of goated. Okay, we can't. Sure, no problem. Okay, so going down here, this is gonna be your A. These points are actually important now. Okay, this is y equals to 2x. This curve is equals to y equals to x minus 3. Okay, so now why does all of this matter? Okay, so now we're looking for this area over here. However, simply integrating the curve will no longer work anymore because that would only give us this, which tells us literally nothing about this. Okay, we need information above the curve. We need information using this line, integration of this line to tell us about what we need to do. Well, not integration of this line, just the area of this line under, using different limits and whatnot. Okay, so a simple thing you can figure out is that if I calculate the area of OBC, the whole OBC triangle, and subtracted it by the area, because see, this is a curve, this is not a straight line. Okay, this is a curve. So if I found out the area of, okay, actually I'm still stuck on that part. Hold on. The integration from, okay, so this is a comma 0, this is b comma 0. Oh sorry, yes, right. And so if we use the limits b a of x minus 3, what does that tell us? That tells us this area over here. Okay, wait, now that just kind of that kind of just breaks my mind because I was thinking this entire time that you couldn't do that. Okay, well, I guess I'm wrong. Since these aren't even although that these aren't interacting with the x-axis, you can still put a limit onto them and kind of then just make them into a triangle, or rather a trapezium, because this isn't a straight line. Each of these, and anyways, even if I did it like, yeah, none of these are straight lines. Yeah, anyways, yeah, it doesn't matter. So yeah, if I did this, now that tells us this area over here subtracted by the entire area of OBC would give us this area over here. Understood? So yeah, I don't think I need to continue with this question any longer. I don't need to erase that. So now continuing with the question that we're actually doing. What was that question before? Yeah. What was the better brush? Oh, okay, there you go. Okay, there you go. And so we have y equals to 12. We have y equals to x 4 plus x. Are we given anything else? No. What we should know is that that's that. We should know that that's that. And we should know that that's gonna be like, let's say we call that G. Okay? So now we are trying to find the area GAO. Okay? To find the area of GAO, we need to find the area of GB, area of GBA. Okay? And the area of GBA is calculated by doing the integration of that starts at 0, that starts at some specific one. Okay, that's gonna be the smaller one, so that's gonna be minus, and plus is going to be the bigger overarching area, which is going to be the area of this rectangle. So it would be using the limits, could we combine it? Are we using the same limits? Yes, we are, right? But I mean, isn't it easier to just, we know the distance from here to here, because this is y equals to 12. So we know that this distance is 12. From O to A, what's the distance? Well, if we do y-intercept over here, x times everything is 0. Wait, what? No. Wait, what the hell? Oh, no, sorry. What is... No. There's no... I'm talking about from here to here. So this is 0 on the x-axis. A is how many from the x-axis. You'll calculate that. That'll also give you what B is. That's going to give you generally what your limit is. Yeah, I suppose you could just put them all under the same thing. So generally, our first cause of action is calculating the limits. So we're going to just be doing simply can I write it like that? Let me just quickly use my calculator. 1 minus 4, sorry, plus 4 minus 12, x equals to 2, x equals to 6. Oh, it says x equals to minus 6 and x equals to 2. Yep, everything's fine. So that is how we can write this down. So we see that x interacts over here with minus 6, and a is going to be 2. If a is 2, then b is 2, 0, and g is 0, 0. A is to 16, and this is 0, 12. So now if we drew just a literal 4 by 4 box now, this is a curve and everything else is literally a straight line. This is a hypothetical line. This is also a hypothetical line. This is the x-axis, so we can just... This is the area we want to find. This is 0, 12. This is 2, 16. This is 0, 0. And this is 2, 0. And I mean, it's not going to be that hard to find out the area. So let's do integral 2, 0 x square plus 4x, bringing in the minus 12. Finally, we're getting this 1 over 3 x to the power 3 plus 2x squared minus 12x. That dx in there. Bam, bam, 2, 0. 1 over 3, 8 plus 2, 4 minus 12, 2. 8 over 3 plus 8 minus 24. 8 over 3 plus 8 minus 24. It's going to give you your negative 40 over 3. Okay, so negative 40 over 3 tells you everything. The question is, where did you... I mean, I'm 100% sure this is correct. The sign is just the problem. But who knows? I might be wrong. It's question number 5. Yeah, no, I'm correct. Just again with the goddamn charge. Charge? I don't know, the sign. What they did here is okay, they didn't combine them together. They just used literally a separate formula, which is like, that's based, do whatever you want, I suppose. Because see, 12 2, what is that? That's 12 2. 12 2 is obviously bigger, yet it has the negative charge, which is absolutely, it makes no sense. Simply, this is supposed to be negative and this is supposed to be positive. Okay, which means in here, when we put in the negative, we have to be aware what is smaller, what is more, what is bigger, what are we subtracting by. This is exactly what my teacher put the most emphasis on. What is subtracting what? When you know what is subtracting what, over here you won't make that error. So if we did this, we don't need to do this again. Let's just rewrite this. So we know the original equation is x squared plus 4x. Now, of course, we know minus. We know the area of the thing is bigger. The area of the line under the line is bigger than the area underneath the curve. So that means it's going to be y equals to 16. Oh, sorry, y equals to 12. Oh God, why did I write 16 here? That's dangerous. Anyways, 12 minus x squared minus 4x. That will lead to hopefully what I think, because the marking scheme says something different. So yeah, minus x squared minus 4x plus 12, that will lead to minus 1 over 3x cubed minus 2x squared plus 12x. Let's check. Minus 8 over 3 minus 8 plus 24. Yep, positive 40 over 3. This is the point. This is the biggest point of this of these kind of questions. This is the hardest challenge to be able to not only remember but apply. So if we have, yeah, that seems fine. We have a line going through this. Yep. So now we have two things. We have this area over here. We have this area over here. Okay. This is x squared plus 1. This is 7 minus x. This point is 7. This point is 0. Okay. So, let's see. Finding R1 is not that hard. Finding R2 is kind of harder. Basically, we just need to know the areas of everything here. I mean, the most vital point is this area. Knowing that, this area over here will give you everything you need to know. But basically, finding the area of this trapezium and finding the area of this gives you this. Find the area of this minus this gives you region 2. So first of all, let's do R1. So R1, in order to find R1, we need to do simply, first we need to find out this limit and this limit. They're not given, so we need to do simply x squared plus 1 equals to 7 minus x. Just want to make sure because I'm scared of getting this wrong. That's 1 minus 6, x is equals to 2, x equals to minus 3. That's perfect. 2 minus 3. So this is minus 3. Minus 3. This is 2. Okay. And now Let's actually get to the meat and bones. Can I do integrals on my calculator? I can. Bruh. Dude, you can do integrals on a calculator? Of course you can. I'm just realizing that this shit is crazy. Oh my god, it's like that feature has always been there. Did not realize. Oh, that's so funny. But anyways, let's do most of it. So you're gonna have we want the area of R1, and you can do this specifically. Now let's look. The greatest area is going to be the line, the trapezium by far. The smallest area is going to be the curve, the area under the curve. So we're going to have trapezium minus curve. Okay, so we're going to do that by 7 minus x minus x squared plus 1, 7 minus x squared minus 1. That's going to be 6 minus x squared. Okay, that's our equation, which we're going to do this, do our 2, do our minus 3, and calculate. Now we're gonna do this because I'm feeling really cheeky. I'm so happy that there's a feature like this. So I'm gonna use my calculator here, find the area. Oh, that's annoying. So 6 minus x minus x squared plus calculate. Bam! Oh my god, it gives you the damn. It just gives it to you. Holy shit! It just gives it to you. That's insane. What the hell? It just gives it to you. Isn't that insane? Well, anyways, now we need to find this limit, and this limit is, of course, it's 0, sorry. So now we do the same exact thing. The trapezium has the entire area. The curve only has this area, so t minus c. So we're going to do the same exact thing, same exact formula, okay, except we're going to be using different limits. Well, this is going to be 2, this is going to be 0, that's the only difference. So anyways, this is going to be region 1. We're going to call this like M. So we're going to call this region 3. So region 3 is equals to that, which is then equals to 22 over 3. Okay, and then we know this region, and we subtract it from the actual triangle. And I don't think I would have ever, I don't think you can really do that by combining these two pieces together, because I mean this triangle is literally just, it's not within this curve anymore. Actually no, you can 100% can. You can, can't you? Because this curve will go on, and if you find it like this, because now the curve has the greater area than this, so it'll be c minus t, which is going to be x squared plus 1. Let's just investigate this. X squared plus 1 minus 7 minus x, which will be x squared plus 1, x squared minus 7, so it'll be minus 6 minus x. Okay, now we're starting from 0, and the area underneath the curve would be, I drew that line. Okay, area underneath the curve would be this. Area underneath the triangle would be this. So when you subtract, you get this. Do you? No. No, you don't, because this curve does not include this part. But the triangle does. So I'm just trying to find a way that I can just combine both of these equations together like we always do. Okay, I guess I don't really have time for that, so let's just... So we found R3, and we can find the area of the triangle by doing integration or just whatever. Do we know the height of this triangle? Yes, we know that this is 7. So this is 7, this distance is 7, this distance is 7. Base times height divided by 2. So base height divided by 2, that's 49 divided by 2. So this whole thing is 49 divided by 2 minus this. So 49 divided by 2 minus 22 divided by 3. Gives you 100 divided by 6. That should be your region 2. Let's see. Do you have anything else that's unchecked? No, we did check that. Okay, so I love this diagram, by the way. I'm in love with that diagram. It's a very nice diagram. Also, this diagram is very nice looking. Except that kind of ruined it with this, but it's like... Anyways, so this is question number 6. It shows 20 divided by 5, 6. That's 25, 6. That's 125 divided by 6. Yep, that's this correct. And next one is going to be 106 divided by 6. That's 1716. That's 17 times 6. Plus 103 divided by 6. Did I get that? Uh-oh. They got 103 divided by 6, not 106 divided by 6? Ugh, man, no, dude. Okay, there's a typo. God, don't do that to me. Alright, that's kind of scary. As much as I would like to prove that correct, I'm not in the energy or time to do that. So, curve has equation holy shit. Holy shit. Verify that C crosses the x-axis at 1, 0. Bro, what do I... Okay. Okay, where do I start? I start with... trying to turn this into an actual fraction. So 1 divided by 3 is quite literally 2 times, 2 divided by 3 is literally 2 times of 1 divided by 3. Which means that if I divide everything by x divided by 1 divided by 3, that doesn't really help. I'm just kind of lost. How do I even start? Like, let's see the marking scheme because this is a lost cause. Okay, they simply just inputted x as 1. So I was overthinking it. When x is equals to 1, this will be 1, this will be minus 2. Over minus 1 plus 1. Or no. Minus 2 over, oh sorry, I'm an idiot. Minus 2 over 1. Yeah. So that will equal to 0 when f of x is equals to 1. Therefore 1, 0 is a thing. Now, show that 8, 4 also lies on the line. So, do I just input honestly moving it down here was a bad idea. This is a weird question, bro. Cube root of 8 is 2. Whole square of 2 is 4. Minus 2 over 2 cube, 8 cube root was 2 again. That's 1 plus 1. That's 4. Minus 1 plus 1. That's just 4. So 8, 4 is a point. So I've proved that 8, 4 lies on the line. I've proved that 1, 0 lies on the line. Now, the point B is 4, comma 0. Find the equation of the line through AB. So now we have, if we plot a graph, we see multiple points. We see 0, 4. We see 1, 0. And we see 8, 4. Okay. Now we do notice that an x has a negative. Would this even be? Well, I mean, isn't this a quadratic actually? Yeah, I mean, it could be like this. You never know. Is point B on the curve? They're saying that. Oh wait, I don't think it's actually on the curve. I'm sorry. Then we can actually do this. Oh wait, is it on the curve? Let's see. So we input 4. F is f of x or f of 4. So 4. So cube root 4 cube root 4 squared minus 2 over 4. Sorry, cube root 4 plus 1. Yeah, it's not that. So this is a separate line, and they're telling us to find B, is find the equation of the line through AB. A being wait no 8 4. Oh my god, dude. This is why you need to label shit, dude. What am I even doing at this point? I just don't know. A 8 4. What is this? 1 0 C. What is this? 4 0 B. Equation of the line that goes through AB. Now the curve crosses the x-axis at the point 1 0, and the point A also lies on the curve. Okay. Can we simplify x to the power 3 minus 2x power negative 1 over 3 plus 1? If x 1 over 3 is equals to y, therefore that is y square minus 2 negative y, no, would that be like this? No idea. If this is this, then what is? I mean, that would just mean this is just simply 1 over x to the power 3. And if you reciprocal this, you want to reciprocal the other side, is 1 over y. So, I mean, more or less they just mean the same thing. This is just a y to the power minus 1. So, let's see, y to the power minus 1 plus 1, right? Now this is the equation that we have, and we see that we have a coefficient of this, which means that we're gonna have two roots of x, two roots of y. But we have a power of -1. It's just what the hell. If you multiply the entire equation by another y, we get a y cubed plus minus 2y 0. That gets rid of the y plus y. Now we have y cubed minus 2 plus y. But this is, I don't think. Okay, we could try. We have how many unknowns? 3. So y, we don't have a square. 1 and minus 2. X is equals to 1 and an imaginary number and another imaginary number. So we know that the 1 root of x is going to be 1, which is true. 1 root of x is 1 over here. That's literally the only root of x. Great. We've expanded it. I still don't know whether this curve is going to be like positive or negative. Like, is it going to go this way or is it going to go this way? I mean, since it has a point here and it crosses this, it can't go like this or else it'll never be able to go back up. So it has to go like this. So now it probably goes something like this. And like this, or maybe just like this. But then I will get 0, 0 for this value. I'm just getting 0. Which gives me like the idea that it's like a cubic or something. Because it only bounces if it's 0, 0. I'm losing it, dude. Holy shit, I'm so tired. Okay, maybe it's time to stop. If I look at the answer, for question number 7. So 8, 4 does lie on the line. Some sort of curve. That's what they say in the morning seam. Some sort of curve. Okay, yeah. So great. My original guess was generally correct. Some sort of curve that's going through here, and they're telling us to find the equation of the line that passes through AB. So we need to find the equation of this line. We have this. We have this. Do you need anything else? You have 0, 4 and 4, 0. Rise over run, yada yada yada. Find it. So rise over run is going to be 0 minus 4 over 0 minus 4, which is equal to minus 1. Sorry, positive 1. So now we have a 1x plus c, y equals to 1x plus c, and we know x values and y values. So when x is equals to 4, y is equals to 0, therefore c is equals to -4, which then tells us the equation of the line is y equals to x minus 4. Now it tells us the region R is bounded by C, AB, and the positive x-axis. It's bounded by curve C, AB, and the positive x-axis. Find region R. Use our favorite brush. So awesome. Region R. So now what we're trying to find is region. Okay, how are we gonna find that? So we have this limit, we have this limit, giving us this whole thing, finding out the area of this tiny thing, subtracting it from this whole thing. So we're gonna have curve minus triangle this time. So that's going to be curve minus triangle is going to be your, what's your curve? Oh, I don't want to write that bullshit, dude. Oh my god. Minus your x minus 4 so indeed you'll get a positive 5 and x. That's going to be your equation, which you're going to do this way, and you're going to use the limits. Because you're going to have the area of the triangle as this. No, hold on. No, hold on. They're using different limits. The triangle is using different limits. Because see, if I use this limit, then we're going to be finding out this area of the triangle and this area of the triangle. That's not what we want. So we need to use different limits. Oh, how annoying now. So this will use the limit 4, 1 minus that's not 4, 1, dude. That's 8, 1. That's 8, 4. Okay, now this is going to just lead in some really complicated, not that complicated, but so you missed this because I sure didn't. Oh man. Okay, yeah. In this case, we probably want it to be in the negative form. So negative 1 over 3 plus 1 is 2 over 3. So it's going to be 2x 2 over 3 over 2 over 3 plus 1x. And this whole thing is going to be done 8, 1. Oh my god, bro. This is, oh my god, integration is difficult. Okay, and this is going to be, well, this is going to be just x squared over 2, 1 over 2, x squared minus 4x. Should I try attempting this? Or should I try skipping? Should I just skip this? I could try attempting it. Let's try doing this like calculator only and like just be very methodical about it. Okay. Let's do everything like literally like unit by unit. Okay, let's do it like that. With the calculator unit by unit. So 8 to the power 5 over 3. 32 divided by 5 divided by 3. That gives us our first number. 2 times 8 to the power 2 over 3 divided by 2 over 3. This is a negative number, so this will be minus 4, right? Plus 1x plus 8 minus, let's not play any games because it's still weird, 1 to the power 5 over 3. Oh no, that's still gonna be 1 over 5 over 3, 1 over 15 minus 2 over 2 over 3 negative 1 over 3 plus 1. Let's find out this value. So 32 over 15 minus 4 over 3, 32 over 15 minus 4 divided by 3 plus 8, 44 divided by 5. Now let's just carry on in this section. So 0.5 times 8 squared. Of course, this is going to be minus. So, okay. 32 minus 8 times 4 is 32. Okay. Did I account for the minus here? Let's see. 32 divided by 15 minus 4 divided by 3 plus 8. Oh, okay, I just skipped this part for some reason. Whatever. I just continue it. So so let's do 1 divided by 15 minus 1 divided by 3 plus 1 and then minus that. So minus 11 over 15, which equals to 44 divided by 5 minus 11 over 15. That's a 121 over 15. I really don't want to get this wrong, so let's just okay. Sorry about that. That was a really stressful stress. I'm not that stressed. I'm just, yeah, it's just a bad day. Bad night. I don't know, man. I don't want to spend my night like this. Just kidding. This is cool. I'm enjoying it. Anyway, so okay, moving on to this side. So let's do this again. 1 divided by 2 times of 8 squared. 32. Minus 4 times 8 minus 32. Okay, cool. 0.5 times 4 squared, 8, minus 4 times 4, minus 8, 8 minus 8. We're having a 0, we're having a 0. I guess that's a law when you have halves, perhaps, I'm just guessing. So this whole thing is a 0. So we're gonna take this, like this. So our final answer is gonna just be this. I'm kinda lost. Where am I? What does that tell us? Does that tell us the area? I don't know, that tells us the area. 21/15. Please tell me that's correct. Please, 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 please. Please. No. Oh my days. Okay, dude, why am I differentiating the triangle, dog? Holy hell. Was I really differentiating the triangle? Why am I differentiating the triangle? Wait, I think I know what I'm doing wrong. And besides differentiating the goddamn triangle. Oh no, I just pressed something and now it's like making a weird loading thing and I don't like that. Oh god. Are you gonna lock it? Oh fine, you're telling me to leave. Ugh, fine. Just give me just 1 second. That's gonna be 4 times 4 divided by 2. Base times height divided by 2, yep. That's gonna be 8. It's gonna be the bigger thing. The bigger thing. There is no, yeah, the bigger thing is that. So 121 divided by 15 minus 8. 1 divided by 15. Which is 5, 5, 4, 5. Okay. I don't know what's going on. Whatever. Till another day. Till another day.